Hey guys, welcome you to the explanation of normal distribution. To get an idea about normal distribution, you have to first have an idea about what's a distribution. I hope you remember that we collected information. When we collect data, we have to analyze them. So as we collect data, we arrange them in an order. And also, for an example, let's say if it's marks of students, we figure out how many students have scored in between 0 to 10, 10 to 20, 20 to 30. We can analyze how many students are there for each mark range. So this is something sort of like that. Right, so I have given you three different types of distributions here. Sometimes the data spread is sometimes the data can be actually spread out more towards the left, so which means you have the peak of this curve towards the right hand side. And if you consider the second graph I have given, then the peak of the graph is more biased to the left. And the third type is where there's no peak, sort of. So they have given it is all jumbled up, sort of. So for an example, let's say these are kind of marks of students. So each bar actually represents how many students have scored a particular range of marks. For an example, it could be marks in between 0 to 10 or 10 to 20. This sort of, right? So now we have to see how by using these bar charts they actually produced the normal curve. Actually, this kind of a bar chart is called a histogram, right? If you ever wondered what is a histogram, this is the idea I can give you. Right, so here you can see from a histogram they are actually producing a normal curve. So below you can actually see the data values, and with the heights we actually get an idea about the frequencies, right? In a normal curve, the specialty is it is symmetrical, and also data values are equally the frequencies are equally spreaded, as in a way from the center to the either side the frequencies are getting reduced. So this is the specialty of a normal curve. We can actually call it a bell curve as well. And then remember, if you have just the bars instead of a curve, we call it a histogram, right? So it says it is often called a bell curve because it looks like a bell. Many things closely follow a normal distribution. So these are some of the scenarios where we actually get a normal curve. Heights of people, size of things produced by machines, errors in measurements, blood pressure, marks on a test, sort of things. And then here I have actually displayed some of the properties of a normal curve. When it comes to normal curve, as I said, it's symmetrical. At the center we actually have mean, median and mode, all three of them as the same value. Remember that. And then from that center to the higher values, and then from that center to the lower values. From that center actually values are spreaded out to either side equally. So 50% of the data values will be on the positive side from the center, 50% of the data values will be on the lower side from the center. So as they even say here, 50% of values less than the mean and 50% of values are greater than the mean. Right, here I have an example. So here they have given heights of males and females. You can see two distributions are actually there, and then also the frequencies are there. So you can see the frequencies are fluctuating. And then by using these histograms they have just created two normal curves. You can see that. And also you can see in these two distributions, though the factor that they have considered is height, you can see based on males and females the mean value has changed, right? I hope you get an idea with that. So it doesn't mean that you have to have the same mean in all the situations when it comes to different normal curves. And then we have standard deviation here. So we have to have an idea about standard deviation before going into questions of the normal curve or the normal distribution. So I hope you remember the standard deviation is actually a measurement that gives an idea from the mean how each value is deviating, sort of, right? That's the idea we get. So if you have calculated the standard deviation, you can actually produce your own a normal curve easily, because to produce a normal curve or the normal distribution, we actually have to know what's the mean and what's the standard deviation. In a normal curve, remember, we can include actually three standard deviations to the positive side and to the negative side. Right, here I have given you a normal distribution. So at the center you can see the symbol mu. Mu actually means the mean value, right? Mu actually represents the mean value. So from the mean value, if you move one standard deviation, there I have mentioned positive sigma. Sigma actually represents, sigma is the standard deviation. So if you move an amount of standard deviation, you actually move to 1 sigma. Then if you move another similar amount, another standard deviation, you go to 2 sigma. Then likewise you go to 3 sigma. So from the center we can go in to either side with these standard deviations. So if they ask you what is the percentage of values included in one standard deviation, then you have to consider both positive and negative side, and then altogether that value is about to be 68.2, because you can see in between one standard deviation we have to consider the positive side and also the negative side. So they are actually represented by the two green color parts, right? So that addition is going to be 68.2%. and then if they ask you how many values are in between two standard deviations, then you can say 95% of all the values are included in between two standard deviations. When it comes to a normal curve, this is like a default value, so you can memorize these facts in order to apply into any normal curve. That's completely fine. And then they have given for 3 standard deviations, this is going to be 99.7. If you wondered how I got these values, so from mean you can see in each colored part I have mentioned what percentage it represents out of all the values that we had collected. So 34.1% of values will be included in between the mean and the first positive standard deviation. But if you consider, if they say how many values are included in one standard deviation, then you have to consider, as I said, the negative standard deviation and positive standard deviation both, right? And then these percentages are actually changing from part to part, so we have to keep adding correspondingly based on how they ask us questions, right? So I have written 1 sigma, 2 sigma and 3 sigma, but now you might be wondering whether after 3 sigma is this section going to be another sigma value. It is not. I actually got this 0.15 like this. So when it comes to a normal curve, we actually can include only 3 sigma values to one side from the center, and from 3 sigma to this 0.15 value, it is not going to be equal to 1 standard deviation. It's going to be less than that. So if you wonder how I got this 0.15, you can see 0.15% is there in either side, so that's going to be a 0.3. I got that 0.3 because here you can see 99.7% amount of values are included in between negative 3 sigma to positive 3 sigma. Altogether, all the values, if you consider, that's going to be 100%. So the remaining values, if you remove this 99.7 amount, is going to be 0.3. That I divided into equal amounts and I put them in either side. So which means the orange color part should contain just 0.15%. Does it make sense? I hope it does. Right. Then we can actually move on to the question and see how to attempt on this question. Right, so let's give our attention onto the first question. Right, I'll read the question first. The time taken by a milkman to deliver to the high street is normally distributed with a mean of 12 minutes and a standard deviation of 2 minutes. So they have given the mean and the deviation to us, which are two important factors when it comes to normal distribution, because as we have these two factors, we can easily draw an example curve, right? I will be heading to what I have drawn according to this question. So right, you can see this. Can you see the below normal curve? Actually, here I have noted down the mean, which is the center of my normal curve, and I have written in the vertical way mu is equal to 12, and as they had given the standard deviation is equal to 2, I moved 2 by 2 to the positive side and also to the negative side. So then I got, as we know that we can move 3 standard deviations in a normal curve. So from 12 to 14, 14 to 16, 16 to 18, I got to the positive direction, and then 12 to 10, 10 to 8, 8 to 6 to the negative direction of the normal curve. Right. So then this normal curve I have to relate to what I had drawn before, because we need these percentage values in order to do the question, right? Remember that. Right, let's head back to the question. Then it says he delivers milk every day. Estimate the number of days during the year when he takes these questions. Right. So the idea of this question is, out of all the possible situations where he have delivered, so based on his delivery times, they have collected a sample data set. So by using this sample data set, they got these properties. They are the standard deviation and the mean, right? And then we are using the normal curve, so that as we have information of a sample, by using this information of the sample, we are going to figure out for a population. So the population could be according to this, the different delivery times throughout an year, which means a 365 days, right? So if we can derive information from the normal curve, then we can figure out within a year how many days he would be delivering milk more than this amount, or whether it's less than this amount, and in between these minutes, on how many days he would be delivering. So that's what we are about to do in this question. So let's move on to what I have drawn once again. So here I have put both the pictures here so you can have a small comparison. The percentage values are going to be the same as I have mentioned in the upper picture. We can use the same percentage values for the lower one. Right, according to the first question, they were asking how many days he would take to deliver the milk that is gonna take more than 17 minutes. Right, let's go back to the question. But actually, sir had changed it to 16 minutes. The reason is, my dear friends, because if you consider 17 here, it's going to be in between 16 and 18. Then it's not going to be easy for you to figure out what's that percentage amount. That's why he actually changed the question to 16. So it's going to be easier for you to calculate that. So 16 to 18, we can actually easily calculate what's the total percentage. Let's see step by step. So I have colored this in green color, so you can easily figure out what's the total percentage. So we can add the two percentages, 2.15 and 0.15 amount, because more than 16 minutes means 16 to 18 and also 18 and above. So that as a total, it's going to be 2.3%. Then this is the percentage value of his all the delivery times. So they are asking how many days he would be delivering milk that he would take more than 16 minutes to deliver. So then I use this percentage to multiply with 365, so we can get the number of days as this. So I got 8.395. As we can round it to 8 days, when you round it to the nearest whole number, you can actually get 8 days according to this. Right. Let's move on to the second question. Right, here they are asking for how many days he would be delivering milk that he would be taking less than 10 minutes. Right, so less than 10 minutes means, according to this graph, you can see So it should be 10 to 8, 8 to 6, and also 6 to the lesser values, right? We have to consider all these area under the curve, right? So it is going to look like this. Is it clear? So you can see 10 and all the low values I have colored. We know that each section has a percentage, so we can keep adding all the percentages together. Then we can get out of the complete graph what's the percentage of the amount of values that I have colored. So then when you add all of them together, you get 15.9%. Then we can see out of 365 what's that amount of days. So I multiply this percentage with 365, so we can get the number of days. Then I got 58.035 days, and you can round it to the nearest whole number, which is gonna give you 58 days, right? Then let's move back to the third question. Here they're asking how many days he would be out of the 365 days, how many days would he be delivering the milk as he takes 8 to 14 minutes. Right, so I move to this. So you can see I used the same normal curve that I had drawn. So I had shaded the region from 8 to 14. So you can keep adding the percentages. 8 to 10 it's going to be 13.6, 10 to 12 34.1, 12 to 14 it's going to be another 34.1. Then you can add everything together, then you get 81.8%. Then I can again multiply by 365 because the number of days per year is 365 in general. So then I get 298.57. This is above 0.5, I mean the decimal part. So when I round it to the nearest whole number, then I get 298. I hope this concept is clear for you, and if you have any doubts, please let me know on the WhatsApp group. I will be helping you out. And also these are the link sites actually I referred to get some diagrams. I'll send you the sites if you want. You can refer to that as well. And yeah, thank you.